Welcome back, friends. Welcome to this lecture series for GATE 2027. So, we are continuing our lecture series. So, this lecture series is for GATE 2027 aspirants and further years, obviously, same syllabus continues. So, we are taking many important topics, and one of the important subject is transportation. Okay, so highway engineering and all. So today we are going to see another very important topic which is asked very frequently in GATE, that is traffic flow models. And students normally get confused between these two models, that is Greenshields model and then Greenberg model. So today we are going to see the difference between them. Yes, today we are going to see the difference between them, and we'll solve some questions also. So now, yeah, okay. So now see, so as I told, we will be discussing this Greenshields model and Greenberg model. So what is Greenshields model? What is Greenberg model? We'll see that, and then next, before starting the class, you can join this Telegram group if you have not joined. Okay. Okay. So let us start. Okay. So first of all, if you are seeing these models relate what? These models relate three things. One is the traffic flow, the traffic density, and traffic speed. So we have this thing known as what? The traffic speed. So there are three entities. First of all, we'll highlight them. There are three entities. One is the traffic speed. So this is traffic speed. And then we have traffic density. We have traffic density. Last but not the least is the traffic flow. Last but not the least is what? Your traffic flow. So traffic flow is in, the unit of traffic flow is vehicle per hour, right? So how many vehicles are crossing in unit time? That is 1 hour. So this is vehicle per hour. Then traffic density is what? It is vehicle per kilometer. That in 1 kilometer, how many vehicles are there? And traffic speed is obviously kilometer per hour. And what is the relationship between them? The fundamental relationship between this traffic flow, traffic density, and traffic speed. The fundamental relationship is Q is equal to K into V. Q is equal to what? Q is equal to K into V. Q is equal to Q into V. Q to K into V. This is the fundamental relationship. Means what? The traffic flow is equal to traffic density into traffic speed. Now this relationship is the relationship between traffic flow, traffic density, and traffic speed. Then we will see the relationship between, then we'll see what? The relationship between the traffic density and traffic speed. The relationship between what? The traffic density and traffic speed. Relationship between traffic density and traffic speed. So when I'm talking about the relationship between traffic density and traffic speed, there can be many relationships, right? There can be algebraic relationship, there can be trigonometric, there can be exponential, there can be logarithmic, right? So two relationships are predominant. First one is the linear relationship. First one is what? The linear relationship. Linear relationship means what? We'll see that. And the second relationship is logarithmic relationship. Second one is what? Logarithmic relationship. Two relationships are important. One is linear relationship, another one is, I just write down linear and logarithmic. So this linear relationship was given by Greenshields. So this is known as what? Greenshields model. This linear relationship between the traffic speed and traffic density is known as what? Greenshields model. And The logarithmic relationship is known as what? Greenberg model. The logarithmic relationship is known as what? Greenberg. So linear is known as what? Greenshields, and logarithmic is known as what? Your Greenberg. Okay. So this is a basic difference. So when you're talking about Greenberg, relationship is what? Logarithmic. Greenshields is what? Linear. So they're two different scientists. So they discovered these two, proposed basically, not discovered, proposed these two relationships. So let us see these two relationships. Okay. First one is linear. So linear relationship is what? The traffic speed is equal to a constant known as free mean speed 1 minus k into k divided by kj. 1 minus what? K divided by kj. So this is what? Linear relationship between, this is the linear relationship between which two terms? The traffic speed and traffic density. You can see there is what? Linear relationship. How? I'll explain here how this linear relationship. See, as I told, this is Vf into 1 minus k upon kj. Now, what is these two terms? This Vf is a term known as what? Free mean speed. It's a constant. It's a constant. And what is this free mean speed? This is the speed of the vehicle when the road is entirely empty. So there is no vehicles on the road, and if you let a vehicle move, that is known as what? Your free mean speed. Then we have a term known as what? Kj. This is your jam density. What is the meaning of jam density? Jam density is the density at jam condition. Jam condition means what? When there is, there is traffic jam. So when there is traffic jam, no movement is happening. So the density at jam condition is jam density, and this is the free mean speed. These two are constants. Now see, if I open this bracket, this will become what? Vf into 1, and this is minus Vf by kj into k. Now see, I will just rearrange this. This will become V is equal to, I will bring this term this side. So minus Vf by kj into k plus Vf. Now you can see this is similar to y is equal to mx plus c equation. Yes, this is similar to what? Y is equal to mx plus c equation, where you see this c is the intercept and m is the slope, right? If you compare here, so this comparison, this becomes the slope and this becomes the intercept. Now this is the equation of what? This is equation of straight line, right? Yes, this is the equation of, we know that this is the equation of, this is the equation of straight line, right? This is the equation of straight line. This is the equation of straight line. So since this is the equation of straight line, means what? Straight line represents what? Linear relationship. So this represents what? Linear relationship. So this is the Greenshields model, where I can write down V is equal to Vf 1 minus k by kj, and I proved that this is linear relationship. This is what? Your linear relationship. This is linear relationship. Okay, this was your Greenshields model. As I told, Greenshields model is what? Linear relationship. Now what about Greenberg model? So Greenberg model, I told that the Greenberg model relationship is what? Logarithmic. So the equation becomes V is equal to Vf, then ln. Ln means log base e. Then here kj by k. Okay, kj by k. So you can see here we have what? Logarithmic relation. Here we have logarithmic, this is linear. So I will again distinguish between two, the Greenshields and the Greenberg. So as I told, the Greenshields model is linear model. The Greenshields model is linear model, and V is equal to Vf 1 minus, here it is k upon kg. And the Greenberg model is logarithmic model, and here the relationship becomes what? Vf ln. Ln means log base e. Here it was k by kj. Here it is opposite. This is kj by e. Sorry, kj by k. Sorry, kj by k. So this is the first fundamental relationship difference between what? Greenshields model and Greenberg model. The fundamental relationship difference we saw. Okay, very good. This is the fundamental relationship difference we saw. Now we will go into the maximum flow condition for both the models. The maximum flow condition for both the models. Now see, for both the models, Q is equal to K into V, because this is the fundamental relation, so it holds good for any model. So this Q is equal to K into V. This is applicable for your Greenshields also. It is applicable for Greenberg also. It's applicable for both of them. It is applicable for both of them. Very good. Now let us first see Greenshields model. So I will see the condition for maximum flow. This is maximum flow, or I can say capacity flow, right? Maximum flow, or I can say what? Capacity flow. Maximum flow, or I can say what? Your capacity flow. Now Q is equal to K into V. Now what I can do is, here you see, this is V, right? This is V equation. So this V equation I can put here. So this will become K into, in place of V I can put Vf 1 minus K upon Kg. I can take this K inside the bracket. This will become Vf K minus K square by Kj. K minus K square by Kj. So this is the equation now of Q in terms of K. So Q became a function of K, right? Q becomes a function of K. Okay, sorry for the interruption. So what we are seeing is that Q is equal to Vf K minus K square by Kj. We saw, right? Right, very good. Now what happens next is, here what we saw that Q become a function of K, right? Q become a function of K, because you see Vf and Kj are constants. So since Vf and Kj are constants, Q becomes a function of K. Now when I want to maximize Q, so for Q is equal to Q max, what we know, that when you want to maximize something, then the differentiation of that function with respect to the variable K should be 0. This is the condition for maximum, right? We know this is the condition for maximum. That means when I differentiate this, this should become equal to 0. Let me differentiate this. So what I got, Q is equal to Vf K minus K square by Kj. So if I differentiate with respect to K, what will happen? dq by dk will become equal to, I will take this Vf constant, this is the constant, so when I differentiate it, K differentiation with respect to K will be 1. I am differentiating with respect to K, so this will become 1, and this will become K square differentiation will be 2 times of K, right? So 2 times of K by Kj. So this becomes equal to 0. What I did? I differentiated with respect to K. I differentiated it with respect to K. So we got this equation. Now what happened? This is equal to 0. Bf cannot be 0. This is a constant. So this has to be 0, right? So I can say 1 minus 2K by Kj is equal to 0. Or I get what? I get 2K by Kj is equal to 1, or I get K is equal to Kj by 2. So for maximum flow condition, what I get? K is equal to Kj by 2. And I can find out V. How? V is what? Vf 1 minus K upon Kj. So in this equation, if I put K is equal to Kj by 2, this will become Vf 1 minus Kj by 2 divided by Kj. So what will happen? This Kj get cancelled. I get a half here. So 1 minus half is half. So this is equal to Vf by 2. So I get for maximum flow, K is equal to Kj by 2 and V is equal to Vf by 2. That's it. Yes. So I can say that for Greenshields model means what? For the linear model, I can say, for the Greenshields model, I can say linear model basically. For maximum flow condition, your K is equal to Kj by 2. So I can say for maximum condition, K is equal to half of jam density and V is equal to half of free mean speed. So what will happen to this Q max? See, we know that Q is what? K into V. K into V. In place of K, I can put Kj by 2 and in place of V, I can put Vf by 2. So this will become Kj by 2 and then Vf by 2 divided by. So this will become, you see, Kj by 2. I'll just write down the whole step. This will become Kj by 2 and then Vf by 2. Kj by 2 and Vf by 2 will become how much? Vf into Kj by 4. Vf into Kj by 4. Okay. Vf into Kj by 4. Very good. So now this becomes the maximum flow for your Greenshields model. And at maximum flow, these are the speeds and densities. Now, similar thing I can do for Greenberg also, right? Similar thing I can do for Greenberg also. I'm not doing the mathematics here. You can do. So for Greenberg model, or I can say logarithmic model, Greenberg model, or I can say logarithmic model, what will happen, you see, if I do the same thing, means what? I will write down this Q with respect to K, then differentiate and make it 0, right? And then from that differentiation, if I solve, I get for maximum flow, what I get for maximum flow, your K we will get Kj by E. See, here we are getting how much? Kj by 2. Here we'll get what? Kj by E. And I can find out V. V equation was what? Vf into ln Kj by K. If I can put this value of K here, Vf ln Kj by, in place of K I can put Kj by E. So Kj get cancelled. Ln E is what? 1. Because log ln is what? Log E. Log base E. Log base E, E will be what? 1. This will indirectly become how much? Vf. So I can say for maximum flow condition, I get K is equal to Kj by E and V is equal to Vf. So what will happen to the maximum flow? Flow is anyhow K into V. So I can put here, you see, in place of K, I can put Kj by E. In place of V, I can put Vf. So this becomes what? Vf into Kj by E. So if I see the differences between Greenshields model and Greenberg model, okay, already we have seen the difference is what? First is the equation. Then what we saw? The maximum flow difference is there. Here the maximum flow is how much? Here the maximum flow is equal to your Vf into Kj by E. Sorry, Kj by 4. Right? And here the maximum flow becomes how much? It becomes Vf into Kj by E. So it is divided by 4, here it is divided by E. And for this maximum flow condition, what is the V? V is equal to Vf and K is equal to how much? Kj by E. And for this maximum flow condition here, in case of linear Greenshields model, K is equal to Kj by 2 and V is equal to Vf by 2. So this is the fundamental difference. So if somebody is getting confused, you can, this table will help. Right? First the equation, and second is what? You can see the maximum flow differences, and the speed and densities at this maximum flow are different. Let us solve one question, 1-2 questions on this, so that we understand this better. So let us solve one question. Suppose let us solve one Greenshields model. Suppose V is given your 80 minus 0.8 K. Suppose this is the Greenshields, it's a linear, looking like a linear model. So this is linear model. So now in this, suppose I can take this 80 common. So what will happen? 80 1 minus 0.8 K by 80. I have taken 80 common. So I have to divide here by 80. So when I divide by 80, so it become 1. So 0.8 by this. This will become, you see, 80 into 1 minus this 0.8 and 80. This will become how much? 100, right? This will be K by 100. So this equation changes form to this form, right? Now from this, if you see the original equation of Greenshields model, it is what? V is equal to Vf 1 minus K upon Kj. So if you compare these equations, you see, you compare these equations, what will happen? You compare the equation, you see, you are getting Vf is equal to 80 km per hour. You can see the free mean speed, how much I am getting? 80 km per hour. Comparing, you see, Vf and 80. And then the Kj will get how much? Kj will get, this is Kj, this is 100. So Kj I will get 100 vehicle per kilometer. Okay. So this is the linear model. So we, from the equation, we got Vf is equal to 80 and Kj is equal to 100. So now when I find out the maximum flow here, in this question, suppose maximum flow is asked. So maximum flow will become how much? This will be simply Vf into Kj by 4. So this will be Vf is 80 and Kj is 100. So 80 into 100 divided by 4. How much I will get? 80 into 100. 80 into 100 divided by 4. I am getting 2000 vehicle per hour. I am getting how much? 2000 vehicle per hour. Now, similarly, if I have a Greenberg, so suppose the equation becomes now 80 ln your 100 by k. You can see this is a logarithmic model, so it's clearly looking what? This is clearly your Greenberg model. So if I compare the equation, V is equal to what? Vf ln Kj by k. So if you compare the equation, what happens? You see, Vf is equal to 80 here and your Kj is equal to 100, right? Kj is equal to 100 vehicle per kilometer. Now in this, if I want to find out the maximum flow, this is your Greenberg model. So I will use Vf into Kj by E, not by 4. I'll use what? Vf into Kj by E. So this will become, you see, 80 into 100. This will become 80 into 100 divided by E. So this is 8000 divided by E. So I am getting a value of 2943.03 something. Approximately I can take this value. So you can see that the maximum flow equation changes, right? The maximum flow equation changes. So this is your Greenberg model. This is your Greenberg model, logarithmic model, and this is your Greenshields model. This is what? Your Greenshields model. This is your Greenshields model. Okay, this is your Greenshields model. Okay. Now, here we saw that, you see, maximum flow equations are different. Here it is Vf into Kj by E. Here it was Vf into Kj by 4. Okay. Okay. Now, suppose it was not asked in this question. Suppose they're asking that if I want to find out at maximum flow, what is the density? The density is how much? It is Kj by E, na? So if I put this Kj by E, Kj is how much? 100. So 100 divided by E, I am getting approximately, you see, 36.8. I'm got 36.787 something, 788, almost this much. Vehicle per kilometer. So at maximum flow, the density is Kj by E and speed is equal to Vf. That is equal to how much? 80 km per hour. That is equal to 80 km per hour. Okay. Yes. So you can see that here at maximum flow condition, I can find out the density Kj by E. They can ask this also. And then, so density is Kj by E and speed is how much? Speed is your 80 km per hour. Yes, speed is your 80 km per hour. Now, if you see this equation, Greenshields, here if I am finding that at maximum flow, what is the density? The density is what? It is Kj by 2, na? Kj by 2 means what? 100 by 2. Kj is 100. So it is 50 kilometer, 50 vehicle per kilometer. And what is the speed? Speed is Vf by 2. That is equal to 80 kilometer per hour. Sorry, 40, sorry. 80 by 2, that is 40 kilometer per hour. So at maximum flow condition, if they ask me the speed and density, that also I can find out here. That also I can find out here. So anything can be asked in the examination, right? Anything can be asked in the examination. Okay. So this was the fundamental differences. So if we summarize, okay, it's very important lecture. Okay. They can ask questions. Already last year they asked a question on Greenberg. They can again ask on Greenberg or Greenshields. So we saw that the fundamental relationship in any model is Q is equal to K into V. Then when it comes to Greenshields, first there are two models, prominent models. One is Greenshields, which is the linear model. Then we have what? Greenberg, which is the logarithmic model. Right? Logarithmic model. Then we saw that in Greenshields when I am finding, then we saw that in the Greenshields when I am finding the maximum flow was how much in Greenshields? It was simply Vf into Kj by 4. And in case of your Greenberg, it is how much? It is Vf into Kj by E. It is Vf into Kj by E. And then we saw here that for this maximum flow condition, right? What was the speed? Speed was Vf by 2. And what was the density? Density was Kj by 2, right? And here, for maximum flow condition, the speed was equal to Vf and K was equal to Kj by E. So these are the fundamental differences and you should be knowing this nicely. Now I'll give you homework, okay? So always, I am teaching, so you should solve some questions also. So I'll give you a homework on this. So please solve the homework and mention the answer in the comment section, okay? So I'll give a homework. Okay, suppose we have a road A. The road A is following Greenshields model. So V is equal to 70 minus 0.7. And suppose road B, it follows Greenberg model, so logarithmic model. And suppose this is equal to 65 ln 90 by A. Now my question is the ratio of maximum flow for road A and B. Road A and road B means what? Basically I'm asking you to find out the ratio of this. Means what? The maximum flow in road A. Okay, suppose I write down B and A, suppose road B and road A. So road B and road means first maximum flow in road B divided by maximum flow of road. So get me this ratio, solve this question and mention the answer in the comment section. Okay, so that's it for the lecture. It's very important points. You should remember this. There's a very good chance that they're going to ask a question on this in your examination. Either they can ask to Greenshields or Greenberg, or they can combine also. They can combine also and they can ask you. And these are the important points you should remember, which can be asked. Thank you very much. So next lecture also will take another important topic. And like this, you see many important topics I have already covered in this lecture series. Okay, obviously we cannot complete the entire syllabus. Obviously, for that batches are there, separate batches are there, or crash courses are there. But still, in this lecture series, I am trying to covering many of the important things which are repeatedly asked in GATE. Like the repeatedly asked questions on topic side distance, on the air voids or voids in bituminous mix. They ask questions on 𝐂𝐚𝐴, like we saw in one lecture, 𝐂𝐚𝐴. They ask questions on Q length, right? They ask questions on this thing which I have discussed here. So like this, they ask many questions. So the important things we try to cover. This is not the entire syllabus, obviously, but if you cover important things, always better. And along with that, if you want to cover the whole syllabus, there is crash courses also. Yes, there is crash courses also. Okay, understood.